Hello, Charger family. This is Mrs. Boyd, Mrs. Boyd's Math Room. Thanks for joining me today when we're going to talk about medians and altitude. So let's get started with medians first. Triangle ABC to the right here shows you medians. If we have medians, that means we're working with congruent segments. So these medians split the sides of the triangle in half. So those two sides are the same. These two segments are the same. And those two segments are the same. Medians happen in the median in the center of the side. Centroid is where the medians intersect. Let me fix that because I wrote it like a 2-year-old. All right, let's look at what we know here. Point D is the centroid of ABC. That means line segment BE is congruent to AE because line CE is a median. If we have segment AF is congruent to CF because line BF is a median. Lastly, we have CG congruent to BG because AG is a median. The distance from the centroid to the vertex is 2/3 of the entire median. So we can say that AD right here is equal to 2/3 of AG. Okay. We can also say that that is equal to 2 DG. So let's talk about this one more time. AD is 2/3 of the whole median, and AD is twice as long as DG. Let's look at another one. ED is the short part from the centroid to the side. So that is 1/3 of the entire median, CE. That is also means that's half the length of CD. So from the centroid to the side is 1/3 of the full median length and half as long as the larger side. Next, we have BD. That's the long side of the median. That is 2/3 the length of BF and twice the length of DF. Let's look at DG, short side of the median. That is equal to 1/3 of the full median, AG, and equal to half of the long side of the median, AD. And we have DC. It's the long end of the median. So that is 2/3 of the full median, CE, and double the short side, DE. That says EE, that means DE. Let me fix that. There we go. Last but not least, we have DF. It's the short side. So that's 1/3 of the full median and 1/2 of the long side, BD. So I hope these make sense to you, these relationships, because we're going to be needing them. Let's scoot on down, get some more facts. The centroid is always in the center of the triangle, no matter what. So at an acute triangle, we have median that looks like that, and like that, and like that. Centroid is in the center, and that's an acute triangle. We have an obtuse triangle here in the center, and our medians look like that one. And like that. So centroid is right there in the center. Last but not least, this is a right triangle. And the centroid is in the center. Makes it pretty easy to predict where it might lie. Let's look at altitudes. Altitudes means you are working with 90-degree angles. And we have an orthocenter. That is where the altitudes intersect. It looks like triangle ABC over here to the right. That means this line coming out of vertex A will make a right angle with BC. From vertex B will make a right angle with AC. And from vertex C will make a right angle with AB. Let's look at some more things we might know about this. Point D is the orthocenter of triangle ABC, which is right here. It tells us that angle AED, let's trace that, AED is going to be congruent to BED. And we know that because this is a right angle. We also know if we have CFD, that'll be congruent to AFD because of they're both right angles. Last but not least, we've got BGD will be congruent to CGD because they're both right angles. So we can say that these all have a measure of 90. And that's how we can tell they're all congruent. For these, the orthocenter can be in the interior, exterior, or this side. Let's see if we can show what that looks like. This is an acute triangle. We want to make a right angle here. And a right angle here. This is awful because my lines didn't cross. It should be like right here. Sorry, good Lord. And then we have an obtuse triangle. So that's an altitude. And then we really need to show, oh, it's okay. I'm going to scoot down just a little bit because we're going to go this way. And I'm going to imagine that this side of this triangle goes that way, and this one continues to go that way. So to get a 90-degree angle, we'd have to go down here and up here. So here is our orthocenter. And for a right triangle, that's 90 degrees, that's 90 degrees, and that's 90 degrees. So our orthocenter is there on the corner of the right angle. Just really some concepts and some vocabulary today. I hope these make all sorts of sense for you. Please reach out if you need any help, and I hope to see you soon.